So now we're going to look at an example. We're going to find theta in a triangle, where a right triangle, where this is 12, this is 9, and this is theta. Okay, so first thing is establish a relationship between the sides of the triangle that are given to you. So 12 and 9, one's the adjacent side of the angle, 12 is the hypotenuse, so adjacent, hypotenuse, cosine. Okay, cosine of theta is adjacent over hypotenuse. Of course, I could always use sine by computing this side using the Pythagorean theorem, but that's more work. So let's just use cosine for that reason. And therefore, theta is going to be the arc cosine of 9 over 12. 9 over 12 is actually the same as 3/4. Arc cosine of 3/4, or if you prefer, cos inverse of 3/4. Now I know my trig circle very well, and I know that I don't know any point that has an x-coordinate of 3/4, because that's what we're looking for, right? Maybe just have a rough idea. We're looking for an angle between 0 and pi. That's for the arc cosine. Right? You be careful, because for the arc sine, it's between pi over 2 and minus pi over 2. But for cosine, it's between 0 and pi. So in the first or second quadrant, where the cosine is 3/4. Cosine is 3/4 means that the x-coordinate of the point on the circle, corresponding point on the circle, is positive. So we're in the first quadrant. So this is 3/4 something, okay? And this is the angle we're looking for. So it's definitely an acute angle, which is reassuring, right? Because we're in a right triangle, so the angle we're looking for is definitely acute. So how do we evaluate cos inverse of 3/4? We don't have, that's not a point like that is one that we, for which we know the angle by heart. So this is where we're going to be using our calculator, okay? And you should have in your calculator, there should be the cosine button. And just above it, you should read something like cos inverse, like that. Okay, maybe in a different color. So in my case, it's in orange. Okay, so this guy is in orange. And I've got this orange second function button. So you have to access the cos inverse by first pressing second function, and then cos inverse, and then you're going to type 3/4. So we're going to calculate cos inverse of 3/4 using the calculator. Now the calculator, it can be either in degree mode or in radian mode. So depending on how it's set, your answer is going to be either in degrees or in radians. And by the way, your calculator knows that the arc cosine gives an angle between 0 and pi, or between 0 and 180 degrees. So that's what you should expect there. So if I've used my calculator in radian mode, it's going to give me 0.0723 radian. Remember, 1 radian is 57 degrees, so this is definitely less than 57. So in other words, it's definitely an acute angle. If I use it in degree mode, it's going to give me 41.42 degrees. So both are just as good. Okay. Now we're going to do a few more examples here. We're going to evaluate the sine inverse of the cosine of 2 pi over 3. Okay, all right. So how do we do this? Well, first of all, I need to evaluate cos of 2 pi over 3. So let's think about 2 pi over 3, where it is. This is pi over 3. This is 2 pi over 3. 2 pi over 3 is 2 times 60, so 120 degrees. So the cosine is the value of this x-coordinate here for that point. So the coordinates here are, so this is where Parentheticals of 2 pi. Remember, we're going to look for the reference angle. Reference angle is this angle here. So it's pi over 3. So for a reference angle, the coordinates are 1/2 root 3 over 2. And the coordinates of our of the point for our given angle, 2 pi over 3, are plus or minus the coordinates of our reference angle. But because we're in the second quadrant, the x coordinate is negative, but the y coordinate stays the same. So the cosine is the x coordinate, minus 1/2. So now we've got sine inverse of minus 1/2. Okay, and now sine inverse of minus 1/2, we're looking for an angle such that the sine is minus 1/2. Okay, and that angle needs to be, because it's the inverse sine, it needs to be between 0 and pi over 2 or 0 and minus pi over 2. But because it's negative, because the sine is negative, we're in the fourth quadrant. We're probably here. Here, all right? So what point would have a y coordinate of minus pi or minus 1/2? Well, the x coordinate would be root 3 over 2. So that would correspond to this reference angle with coordinates of root 3 over 2, 1/2. I know this is pi over 6, so this must be minus pi over 6. Like that. Let's do another one. Sine inverse of sine of pi over 3. Okay. Now, okay, sine inverse of, so sine of pi over 3, we're actually did part of the work here. This is pi over 3. The point is 1/2 root 3 over 2. The sine is root 3 over 2. And for the arcsine, we're looking for an angle. Clearly that's in the first quadrant because sine is positive, where the sine is root 3 over 2. And, well, that's, right, if we're looking for an angle where the sine is root 3 over 2, the x value would be 1/2, and this is pi over 3. So this is an example, actually, where sine and sine inverse cancel out each other. So we fall back on pi over 3. That's because pi over 3 was initially in the range of, or in the domain of a restricted sine function, which is the range of the inverse sine function. Remember, from minus pi over 2 to pi over 2. So whenever you have an angle in that range, it's going to give, if you do sine inverse of sine, it's going to give you back the number you had initially. So this is like doing f inverse of f of x, we get back x. Okay. But with the sine functions, you have to be careful. The x here, it has to be in the range of the inverse sine function. So let's look at C. C, we have something similar. You see, you have sine inverse, but this sine of 2 pi over 3. And I'll tell you right away, this is not going to give us 2 pi over 3 this time, because this is not in the range of our inverse sine function. Okay, this one was. So that's why it gave us back pi over 3. So here you'll see, this is why I'm doing this example, it's not going to give us back 2 pi over 3. Okay, in other words, the sine inverse and sine do not cancel out each other in this case because of the input 2 pi over 3. So sine of 2 pi over 3, what is that? 2 pi over 3. Okay, pi over 3, 2 pi over 3. What's the sine? Well, the reference angle is pi over 3, so this is 1/2 root 3 over 2. 2 pi over 3, it's minus 1/2 root 3 over 2. The sine value is root 3 over 2. Okay, now the sine inverse is asking us for an angle between minus pi over 2 and pi over 2. where the sine is pi root 3 over 2. And that occurs at the point 1/2 root 3 over 2 for an angle of pi over 3. So this is pi over 3. So even though we started with 2 pi over 3, now we end up with pi over 3. Let's do another one. Sine of cos inverse of 4/5. Okay. Let's try to get the exact answer. So those are all problems, by the way, we could do with our calculator, but I want to do them exactly here, at least, yeah. So let's first look at what this is. So this is an angle, because it's an inverse cos, okay? So the angle is such that the cos of the angle is 4/5, okay? So let's take a look at, because ultimately we want to find the sine of the angle. So we're going to create a triangle maybe to work this out. So the cosine is 4/5, like that. So using the Pythagorean theorem, we could find what this side is, because we're not going to need it. Okay, because to find the sine of theta, this is just going to be opposite over hypotenuse. But the hypotenuse is 5, so I just need the opposite side. What's the opposite side? Well, we know that 4 squared plus the opposite side squared is the hypotenuse squared. So the opposite side squared is 25 minus 16, which is 9. So that makes the opposite side equal to 3. So I get that my sine is 3/5, okay, without even using my calculator. Of course, you can check this out with your calculator. You should get 0.6 for your answer. So that's a cool way of evaluating the sine inverse of a sine or a cosine using a triangle. And last example, cos of sine inverse of 1/3. Okay. So this is again some theta. So we're looking for cos of theta, where sine of theta is 1/3. So in a triangle, if I've got sines, this is 1/3. I can calculate this side. This side is what? This is going to be 3 squared minus 1 squared, square rooted. So this is square root of 4 minus 1, so square root 3. Oh, sorry. This is not, I don't know why I wrote 4. This is not square root 3. This is 9 minus 1. So this is square root 8. And this is 2 root 2. So this side is 2 root 2. And so I want to calculate the cos of theta. And cos of theta is adjacent over hypotenuse. So it's 2 root 2 over 3.